Okay, here, ladies and gentlemen, we're going to tackle some more challenging special triangles problems, as well as just some more challenging trig problems that review some skills from some previous units. So we'll jump right in here in a second. Again, make sure you understand the solutions to all these because you're going to see similar problems in the quiz. And as always, feel free to jump around. You don't have to watch this video in order if you feel like you have a good grasp on the solutions to some, but not all of the problems. Here, we're looking for the length of AD. Right, so AD is here in this first one. And this is challenging because we have multiple triangles. We might have multiple steps happening here. Let's think a little bit. So we know that this angle is also 90 degrees because they form a straight line together. 90 plus 90 is 180. And then we know that this angle's got to be 60 degrees. And we know that this angle's got to be 30 degrees by triangle sum. Right, so in order for those little triangles to add up to 180, that has to be true. And then these two triangles, our two smaller triangles, are actually the same. They're just mirror images of each other. They are congruent. So we know this length is going to be 12. And then to make this a little bit clearer, maybe we draw just ABC by itself. We have 60 and 30. So we have a 30, 60, 90 triangle. And then my short side is going to be x. My medium side is going to be x square root of 3. And then my big side is going to be 2x. And you could use your notes as a reference if you don't have that memorized. And then this becomes pretty easy, right? So 2x equals 12, x is going to be 6. Okay. This is often helpful to draw a little sketch when you have more information than you need in one picture. I can just sketch the triangle that I need down here. Okay. My second one looks similar at first glance. So I am tempted to use 1 square root 2 because I see this square root 2 in here already. But notice it doesn't quite fit the pattern, right? So this is my right angle. And then what we have is not necessarily congruent sides. And the root 2 side should be on the hypotenuse, right? So this is not necessarily a special triangle here. In fact, even if it were, a special triangle would not be the easiest way to solve this. So let's think about what this says right away. So it tells us BD bisects AC. That means cuts it in two equally. 7, 7. And we'll do the same thing we did before. So we want the perimeter of ABC, which means we have to add up all the sides. Let's just worry about DCB. Let's just worry about that right-hand triangle. So we have 4 root 2 and 7. Well, we have a really easy way to find that third side, right? So I do 4 root 2 squared plus 7 squared equals c squared. That gives me, let's see, 16 times 2 is 32 plus 49 is c squared. This gives me 9 for that side. And notice we have two congruent triangles again. So 9, 9. So we're just doing 9 plus 9 plus 14 if we want the perimeter. So that gets us 9 plus 9 plus 14. Gets us 32. Okay. So all the tools in your toolbox are still available to you. And you can use Pythagorean theorem, or you can use just like plain old SOHCAHTOA, if that's the easiest way to solve the problem. Don't think that just because it's a special triangle, or just because it has a square root in it, I guess, it's a special triangle. Alright, let's move on to the cool ones here. So this one, you really want to draw for this one. So this one, I'm going to say I have a right triangle. And it tells me B is 90 degrees. And I'll just label these other two A and C. BC it says is 16, and AC C, it says, is 20. Okay? And then it tells us about DEF, which is similar, meaning proportional, to ABC. So DEF would be, it says it's 1/3 the length. So 20 over 3, I guess we could say, if it's 1/3 the length, and 16 over 3. Now, this is, I believe, a no calculator SAT problem. So if we're real clever, we can find an easy way to solve this without a calculator. So it wants sine of f. So sine of f would be opposite over hypotenuse. And right away I'm seeing that there's these like fractions in here, which is kind of nasty, right? Well, if these triangles are proportional, that means sine of f is going to be the same as sine of c, because angle f is equal to c. This little squiggly 3 equals sign means congruent, meaning same in geometry. So what I can do is find the sine of c, and that's also the sine of f. Now what we'll get here, we can do Pythagorean theorem, and we'll get 20 squared equals 16 squared plus b squared. And the result you get is 144 equals b squared, and b equals 12. Now I'm skipping some steps there, and you're probably thinking, well, how could I do this without a calculator? Notice we can also draw sort of a smaller version of ABC and just reduce it, kind of by the same logic we have here. But so this would be, let's say we divide it by 4. We notice there's a common factor there. 5, 4, and then we have 4 squared plus b squared equals 5 squared, and this would give us 3. Okay, so these are the same triangle, and just multiplied. The small triangle times 3 gives me the big triangle, right? So I could say for sine of c, we have opposite over hypotenuse. I could say this is equal to 12 over 20, or I could say this is equal to 3 over 5. And notice this is just a reduced version of that. Okay. So that's how you tackle that one without a calculator, is by reducing that. That's some pretty high level reasoning. So for the purposes of this class, it's okay if you used a calculator to do this, right? And gave me 12 over 20, because these are equivalent. I don't need you to reduce that. So either answer is fine here. Okay, so last two, this is just a little review of finding a trig ratio from a point. So I'm going to plot my point. 3 comma negative 4 is going to be down here somewhere, right? And what I really care about here is that this vertical distance is negative 4, the line segment going to my point, and then this horizontal distance is 3. We'll say sine of theta is what we want. We want opposite over hypotenuse. So we need to find the hypotenuse. And we can do Pythagorean theorem. 3 squared plus 4 squared equals, well, I gave it away, c squared. But this is a 3, 4, 5 triangle like we just saw actually. So we get 25 equals c squared, and c equals 5. Okay, now the sign here matters. So if you didn't put this negative here because we're coming down from the x-axis, we would get this one wrong. So negative 4/5 is what we want to say, because we're looking for opposite over hypotenuse. So C is my solution there. And my last one is similar, although it's now asking you to kind of understand how these rotational angles works. So 60 degrees means I'm going to come down, sorry, negative 60 degrees means I'm going to come down from my x-axis, and this is going to be a 60-degree angle right here. Okay? And now we're going to use our knowledge of special triangles. So opposite 60 is going to be my square root 3 side. My hypotenuse is going to be 2, and my short side is going to be 1. Now, the signs here matter, right? So I'm to the right of the origin, so my 1 is positive, but I'm below the origin, so my square root 3 is negative. Okay, so the first step here is to draw our reference triangle here. And then let's remember what this is. It says secant. Let's remember what secant is. Secant is the inverse of cosine. So secant of an angle is the hypotenuse of the triangle over the adjacent side. So that is 2 over 1. So C is the solution. So notice the signs can matter, but did not in this case. So if I'd asked you for like sine of 60 degrees, negative 60 degrees I should say, then negative would matter here, but these both happen to be positive. So we're just going to say C and call it good. Okay, as always, make sure you understand the solutions to all 5 of these before you move on, because very similar problems are going to show up in your quiz.